Greetings of the day, dear students. In this video, we are going to discuss about the principle of operation of synchronous motor. We will see its operation and we will explain clearly why it is not a self-starting machine, why it is not inherently a self-starting machine, right? Why some external force is required to set the machine into motion, right? And what are the different terminologies we are having, what are the different cases we are having in this video, right? Before going to that, let me define the terminology involved here. This indicates in this figure, this is the stator frame and this is the rotor, right? For our convenience sake, let me assume the machine is a two-pole machine which is having two poles. One is the north pole and another one is the south pole. Here NS indicates the north pole of the stator, NR indicates north pole of rotor. Similarly, SR south pole of rotor, SS south pole of stator. Now for the stator winding, three-phase supply will be given. Because of that, what happens? Because of the given three-phase supply, some resultant magnetic flux will be produced. Now the magnitude of the flux will be constant, but the flux will be rotating or revolves, right, at a synchronous speed. Now this flux will be rotating at the synchronous speed. Now assume it is having north pole. NS indicates the north pole of the stator. At that time, in figure A, at position A, at point A, we are having the north pole of the rotor and the north pole of the stator at the same position. Obviously, here the stator south pole and the rotor south pole are at the same position. At that point of time, this rotor is going to experience a torque, because north pole and north pole will get repel each other and the rotor is going to experience a torque, and because of that this rotor tries to rotate in the anti-clockwise direction, right? Now by the time this revolving flux or rotating flux changes its position, the rotor fields will not be in a position to catch up the rotating field. How do you understand that? Already the stator has changed its fields. Here at position A we are having stator south pole, but still we are having at that point rotor's north pole, right? So the rotor is unable to change its position quickly. But already the stator field has rotated or changed its position. But rotor is unable to change its position. It is unable to catch up. Because of that, what happened now? At position A, we are having stator south pole and rotor north pole, which will attract each other. Now again this rotor is going to experience the torque, but this time because of that it has to rotate in the clockwise direction. So what happened now? Alternatively, it is experiencing the torque in opposite directions. One time it is making it tends to rotate in the clockwise, and another time it is tends to rotate in the anti-clockwise direction, right? So because of what we have to do is through some external means we have to make the rotor also rotate at the synchronous speed. We also want to make the rotor also rotate at the synchronous speed by some external means. If we are able to do that, then obviously what will happen, in each and every time there will be the production of the unidirectional torque. Now see here again the stator has changed its position, but by that time now here we are having stator north pole here and rotor south pole here. Both will attract each other, and again it will experience a torque, and which tends to rotate in the clockwise direction. So here, due to the continuous and rapid rotation of the stator poles will be rotating at its synchronous speed. There is no doubt. It is undergoing continuous and rapid rotation. But rotor is also, because of that, rotor is subjected to what? Rapidly reversing the torque. So here, which tends to move the rotor one time in the one direction and another time in the opposite direction. Because of the large movement of inertia, rotor cannot respond to such quickly reversing torques, which makes it to remain stationary. Because this large movement of inertia, rotor cannot respond to the quick reversal of the torque, right? And because of that, it remains in the stationary mode. That is the reason why we will call it this three-phase synchronous motor inherently is not a self-starting machine. Now, how to solve that? What to do? The stator poles are changing very quickly, but rotor poles are not in a position to rotate at that much speed. So what we have to do? The thing is, see here, by some external means, if rotor poles, in this entire discussion, this is the key point, if rotor poles are also made to rotate, right, through the half the revolution during the same period, then what happens? Both stator and rotor poles will attract each other. That means either at a time, north pole of stator and north pole of rotor will be at same position, and similarly south pole of stator and south pole of rotor will be at the same position. Then what happens? They will experience the attracting force, and torque will be unidirectional. Torque will be produced. Now this rotor will be speeded up. How to do that? This rotor will be made to speed up with the help of another motor. That speed must be such that equals to the synchronous or near synchronous speed of the rotor. To how much speed you have to make it rotate? Equals to the synchronous speed by some external means. So it is the method of starting the synchronous motor. Once if you brought the rotor into its synchronous speed, then the excitation current of the rotor poles will be switched on. Now the excitation, how we provide excitation? With the help of some small DC machine which will be mounted on the same shaft, right? With the help of that, the windings of the rotor will be excited, right? Now once the poles are got excited, they will be magnetically locked into the position, right? So because of that, stator poles of opposite polarity, that is the rotor poles, are engaged with the stator poles and both run synchronously in the same direction. So in this discussion, principle of operation, the important key point is, through somehow we want to make the rotor rotate at the synchronous speed by some external means. That is very, very important, right? At a time, both must be under the same position. North pole of stator, north pole of rotor should be at the same position. Similarly, south pole of rotor and south pole of stator must be at the same positions. So it is because of this interlocking nature of rotor and the stator poles, the motor has to either run at the synchronous speed or not at all, right? So this is the all about the principle of operation of synchronous motor. If you remember these diagrams, it will be very easy for you to write the theory. Just one time, what you do is, you take north pole of stator and north pole of rotor under at same position, and assume the direction of ns in clockwise, and both will get attract each other, and it is going to experience a torque, and represent the torque in the anti-clockwise direction, right? Slowly change the position of the stator first. By the time stator has changed its position, observe here, initially at A, what is there? Initially at A, ns is there, but in the same figure B, At position A, what is there? SS is there. Stator south pole is there. But rotor has not changed its position. By the time stator has changed, rotor has not yet changed its position. Because of that, what happens? Again, it experiences a torque. But now this time, this torque makes the rotor rotate in which direction? Clockwise direction. So like this, it is experiencing alternating alternating torque, right? So through somehow make at a time north pole of stator and north pole of rotor at one position, and south pole of rotor and south pole of stator at one position. This can be done with the help of some external means, with the help of another motor, which makes the rotor rotate at the synchronous speed, right? Thank you.